investigation into finding the limiting reagent in a chemical reaction. First, introduction. Stoichiometry is the section of chemistry that contains relationship between either reactant and or product in a chemical reaction to assist in determining the required quantitative data. Stoichiometry is used by chemists to give a detailed explanation on how much of certain materials are required in order to make a certain number of given product. No product would be able to be made without chemical stoichiometry using balance equation to calculate the number of product needed in order for a certain amount of product to be formed. This can be often be seen through the use of limiting and excess reagents and how much of one substance is needed to produce this n amount of solution formed. This can often be seen through the use of limiting and excess reagents and how much of one substance is needed to produce this n amount of solution format with most minimal expense possible. The theoretical yield, the number of products created by a completed chemical reaction given the amount of the reactant was and everything was balanced. Theoretical yield calculation of an equation takes into account the moral amounts of the reactant and product and clarifies that enough of each reactant is present in order for the reaction to be done completely and correctly. The investigation aimed at testing different amounts of aqueous sodium iodide being reacted with a fixed amount of aqueous lead nitrate and the dissolved yellow lead iodide prepared format in measure 2. Study the influence of the limiting reagent in the product. The balanced chemical equation of the reaction between the aqueous lead nitrate and sodium iodide show that the molar relation between the two is 1 reverse equation 1. Aims. The second is aims. The aims of the investigation was to test the limiting reagent in a reaction where numerous different masses of sodium iodide is reacted with fixed amount of lead nitrate and the lead iodide precipitate format is created and analyzed. Third, hypothesis. It can be hypothesized that this 1.66 grams or lead 2 nitrate is reacted with different amounts of sodium iodide, then the maximum amount of sodium iodide that can be reacted to produce the perfect amount of lead iodide will be 1.5 gram and the maximum amount of lead iodide that can be formed is 2.31 gram refers to appendix for calculation. This is due to the balanced chemical equation showing the mole ratio. Fourth is discussion. Experiments results show a steady increase of lead iodide. During the experiment, there were many errors that could be seen when calculating this data, including the measuring of the lead nitrate as well as the sodium iodide. For future investigation and experiments, some areas for improvement included being more accurate with the measuring of the lead nitrate and the sodium iodide, as well as being more accurate with the time stirring the mixture and the time in which the mixture are left overnight to set into the funnel. This investigation assists in giving a proper investigation into the improvements of what a limiting reagent is and how important it is and experiments. Conclusion. In conclusion, the aim of the investigation was to obtain enough quantitative data. The experiments where the fixed amount of PbNO32 is reacted with varying amounts of product format in the reaction. Experiment is supported to the linear trends, but could be improved by the experiments being conducted with modification to the method, ensuring that all the products are measured currently.